In previous session, we had discussed about the very basic points of about the control system. Today, we are going to discuss. I am Sumangala from entity of Belur, assistant manager. So today we are going to discuss about the classification of control system. So control system is classified into two types, two categories. One is open loop control system. Another one is closed loop control system.
What do you mean by open loop control system? So definition of open loop control system. So a system in which control action is totally independent of the output system is called as open loop control system. Here what happens, there will be a reference input for a signal, and the system is generating some desired output, but here the verification whether the desired output is achieved or no, it will not happen automatically, or manually we need to observe whether the desired output is achieved or no. Example, the open loop example is electric hand dryer. So here we are not like how we use electric hand dryer. So hot air is blown when hand is detected near the electric hand dryer, right? But it doesn't make sure that the hand is completely dried or no. There is no signal going to your hand dryer, electric hand dryer, correct? So next example is automatic washing machine. So washing machine, it is programmed to wash the clothes. It spins, it washes, it dries, but it doesn't make sure that there is no signal going from your cloth to the machine controller unit that the cloth is 100% dirt free. Hence we call it as an open loop system because it is not checking the output. Next, bread toaster. Here, irrespective of the what type of bread roast you want, irrespective of the timer is set based on the time, it will be toasting your bread. You have a choice that to select the timer. That's it. Irrespective of your choice, your amount of roasting, it will roast the bread or toast the bread and it will pop out. Correct? So output, we need to manually observe whether the bread is properly toasted or no. According to that, I have to turn off the bread toaster. Automatically, it is not turning off. Next, another example for open loop control system is automatic or tea or coffee vending machine. Here, the vending machine, it functions according to the pre-adjusted time only. So when you take the cup near to the vendor machine, it dispenses the coffee based on the timer. It doesn't like based on requirement. For example, I need a little amount of a coffee or a tea to be dispensed. I cannot choose that. According to the timer set, it will be deciding, and I should manually monitor it, and I should check whether how much amount of coffee or tea required, that much I have to take and I have to turn off. So next, open loop control system, one more example is that light and a switch. When you turn on the light is on. Irrespective of that, we have smart light system nowadays, wherein automatically based on the sunlight, the street lights will be on and off, correct? But here, the switch is operated manually, then only light is going to be on, otherwise it will be off. So this also becomes a open loop control system. The volume on a stereo system. So volume is adjusted manually to control the level of the volume. So if you are reducing the volume, it will be lower. Otherwise, you have to manually control. Automatically, based on the requirement, the volume is not adjusted. So now we are going to discuss the advantages of the open loop control system. The system is these open loop control systems are very simple in construction and design. And because of the simple design, it is less expensive, the cost is low, and they are very easy to maintain, and they are very stable operation, since very less amount of, there is no complexity in design and maintenance, and hence they are very stable. They are having a very stable operation, and they are very convenient to use whenever the output is difficult to measure. What are the disadvantages of the open loop control system? They are very inaccurate compared to closed loop control system. Okay, so when accuracy is a high priority, for example, in a research field or in a military applications, in defense field, the high accuracy, and in medical assistance field, so we need high accurate outputs. So based on that, we'll choose the type of system. They are inaccurate compared to closed loop control system. The applications which example which I told, there that cases we can go opt for the closed loop control system. They are unreliable. So accuracy is a challenge. Hence, they are unreliable. The output cannot be very high precision value. Any change in output is not corrected automatically. We need to manually observe and correct the system. Okay, so next topic is the closed loop control system. So in the closed loop control system, we have a privilege that it's having a feedback. So system in which the action is somehow dependent on the output. So in closed loop control system, we have a feedback signal that is like a part of output, or a output signal is modified and sent at the input side, and this signal we call it as a feedback signal. So here if we observe, this input signal is given, and the controller unit is there, and the plant is processing, and it is generating output. Here the output signal is fed back to the input side. So what happens when I am feeding back the output signal to input side? So here there is a reference value which which is the same as a desired value from that system after that process. So when I am generating output, a part of that output or a signal, output signal is fed back to the input side. It is compared with the reference signal, which is predetermined a required value from that system. When it is compared, it should be same. The output generated and reference signal, the feedback and the reference should be same. But if any deviation is there in that, either feedback and reference value are not similar, then there will be error signal generated. They should be same actually. The reference is a desired value which is predetermined, and feedback is a actually generated value which is fed back to the system. So the difference should not be there. If there is a difference in these two signals, that is called as an error signal. That error signal actuates the actuator, and actuator in turn actuates the controller. The controller unit manipulates the signal in such a way that the error is corrected automatically, and it is fed to the plant. Again, processing happens and it generates the output as per the requirement. And the flow of the signal from input to output side is called as a forward path, and when output is fed back towards the input, this is called as a feedback path, okay, or a reverse path. This is all about the closed loop control system. So next one is the examples for the closed loop control system. Here one simple example, that is for closed loop control system, automatic electric iron machine. So here what we are doing, iron machine helps us to press the cloths, but I can choose here what temperature I want to set for according to the cloth. And also when I'm setting the temperature, I can make sure the temperature is varied, going above or below the set temperature. Automatically the iron box is getting switched off, correct? So this can be an example for a closed loop. I am not turning off the iron box. Automatically, when the temperature is exceeding or it is reducing, I can install one sensor to measure the temperature, and it continuously reads. For silk cloth, particular temperature is required. If it goes above or below the reset range, automatically the iron box will be turned off. And this is one of the another example, closed loop control system, servo voltage regulator. So this regulator circuit, here we have a buck boost transformer and auto transformer. And here the load connected, if suppose load is expecting some voltage. Suppose there is a high voltage input side, or there is a voltage fluctuation in the input side because of many reasons will be there. So this buck boost transformer and auto transformer make sure that the load gets the required amount of voltage for its functioning, so that it protects the load. We have stabilizer in our home, right? It does the same functionality. How does it do? So there is a buck boost transformer which either increases or decreases the voltage coming out of this transformer. Okay, so it performs both buck and boost, correct? So buck means reducing the voltage, boost means increasing the voltage. It have both the activities, or it perform both the operations. It increases the voltage, it decreases the voltage according to the requirement. If voltage is high, voltage is coming, it controls that voltage. If less voltage is coming, it controls the voltage and boost it, and it gives to the load, so that load gets controlled voltage always. And here we have auto transformer. Here what happens, there is a control circuit, motor driver circuit is there, servo motor is connected here. So when here we are, for control unit, we are checking whatever output coming from the transformer, we are connecting here. So what happens when control unit is detecting that here reference value will be there, what actually voltage to be transmitted to this particular device. Assume that it is a fridge or a washing machine or a TV. So what exact voltage is required for that? Then control unit decides whether any deviation is there or not. It compares that signal with the reference value. If deviation is there, it gives the control unit, maybe microcontroller or any simple processor, correct? So this sends a signal to the servo motor, so that servo motor operates. So that when servo motor operates, the auto transformer automatically, the center tap, this transformer, it varies the it also moves. So when it moves, the voltage is varied. In this way, it is either buck or boosting the voltage and make sure that constant voltage reaches the load. So here also water level indicator or water level controller. So in industries, we have a lot of liquid tanks in hydraulic pneumatic hydraulic industries. We use a lot of liquid tanks. We need to control the pressure of the liquid or the amount of liquid in the tank, correct? And also maybe it is a water that also to be monitored in the tank. So I can closely monitor the level of the water in the water tank, so that the conductivity, see, we know that the liquid conducts, correct? So here there is a water supply, and pneumatic rotary valve is there, which operates on the pneumatic. So here solenoid valve is there. Here's conductivity probe controller is there. So here when the level, each level it is reaching, it conducts, and that signal is fed. Here, this is a 4-level conductivity probe. So when the water level reaches here, some voltage is transmitted, so that it operates the pneumatic valve a little bit, so that it controls the water supply. When it reaches second level, again some signal is sent, so that it automatically operates the, and when maximum level reaches in the water tank, so that particular voltage is enough, it triggers the solenoid valve, and rotary pneumatic valve is operated, and it closes the knob, so that water supply is completely turned off. What are the advantages? This is all about the example for closed loop. And now we'll discuss advantages of closed loop control system. So advantages of closed loop control system are, the closed loop control system are very accurate compared to open loop control system. It facilitates the automation, and this system is very less affected by noise. Means external noise signal if get added also to the system, if some glitches, some noise added to the system also, it can be rectified when we are sending a feedback, correct? We are automatically, systems are corrected. So disadvantages of closed loop control system are, they are very costlier because of the system design and complexity in the design. They are complicated to design and require more maintenance, and stability becomes one of the challenge because more complex circuitry is involved in this, and more complex design is there. That's why the stability becomes a challenge. So now we will conclude with the difference between the open loop and closed loop control system. So here are the some open loop and closed loop control system. Comparison between open loop and closed loop. Definition: the open loop is here the output is free from the system control action is free from the output, and closed loop, the output depends on the control action. No feedback in the system in the open loop. Feedback is present in the closed loop. Controller and control process is absent. Manually it is installed, and amplifier, controller, control process, feedback, all are present in this. And example for open loop: traffic light, automatic washing machine, immersion rod, TV remote, etc. Closed loop: air conditioner, temperature control system, and iron box, speed, pressure control system, refrigerator, and a toaster. These all are example. Thank you for your time. Thank you for watching my video. If you like my channel, please like, share, and subscribe. Hit the bell button. Thank you very much.